There will be 4 free response questions on the AP Precalculus exam. This video is modeled after FRQ1. Let's pretend it's from the 2006 AP Precalculus exam. FRQ1 is about composition, zeros, limits, and inverses. If you appreciate this content, please give it a like. The graph of function f is shown. The function f is defined on the closed interval between 0 and 9 and consists of 3 line segments as shown in the figure. The function g is given by g of x equals x to the third power plus 3x minus 23 over x minus 1. Part A. The function h is defined by h of x is equal to g of f of x. Both of these notations mean exactly the same thing. Find the value of h at 6 as a decimal approximation or indicate that it is not defined. H at 6 means plug in 6 for x, so that gives us g at f at 6. What is f at 6? Well, looking at the graph, here is 6, f at 6 is 1. So we can substitute in a value of 1 for f at 6. That gives us g at 1. This problem is calculator active, so let's type g of x in as y1. First, it's a good idea to reset your calculator at the beginning of every problem. You hit second plus 7, 1, 2. Again, that is second plus 7, 1, 2. Fresh calculator. Always use a vertical fraction on your calculator instead of using the division sign. If your software is up to date, you can just hit alpha x like that. Otherwise, you have to hit alpha y equals and then enter. Once you have it all typed in, quit your way out to a blank screen. We need to evaluate g at 1, but we just typed in g as y1. So we really need to evaluate y1 at 1. To make y1 appear on your calculator, hit alpha, trace, enter. To evaluate y1 at 1, just put a 1 in parentheses next to the y1 and hit enter. Let's look back at our work and see why we are getting this division by 0 error. We should have known from the start that we cannot evaluate g at 1 because of the denominator. If you plug in 1 for x, 1 minus 1 is 0. You cannot divide by 0. So g at 1 is undefined. Be sure to indicate that h at 6 is undefined like this. A part 2. Find all values of x for which f of x is equal to negative 2, or indicate that there are no such values. Here is an output value of negative 2. F is equal to negative 2 at an input value of 2 and at an input value of 9. In other words, f of x is equal to negative 2 at x equals 2 and at x equals 9. B part 1. Find all values of x as decimal approximations for which g of x is equal to 7.2, or indicate that there are no such values. Remember, we have entered g of x as y1 on the graphing calculator. We can find where g of x is equal to 7.2 by graphing y equals 7.2 on the calculator and finding the intersection point. Let's just type in 7.2 as y2, and let's go ahead and hit graph. If you reset your calculator at the beginning, it automatically set your window to negative 10 to positive 10. So hit graph, and it should look like this. We can see the intersection point right here. We can find it by hitting second trace and choosing option 5 for intersect. I don't see the pointer, so pro tip, hit the up arrow key, and that will make the pointer appear. Move that pointer close to the point of intersection and hit enter 3 times. Enter, enter, enter. And there it is, 3.0599. The College Board requires 3 decimal place accuracy. However, students will often lose a point unnecessarily by trying to round and then rounding wrong. So I strongly recommend always using 4 decimal places and don't try to round. I'd like to be sure that there are no other intersection points, so I'm going to zoom out. So hit zoom and 3 and enter. Okay, so I feel like I can see kind of the whole function now, and that was the only intersection point. B part 2. Determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. As x increases without bound means the limit as x approaches infinity. So let's begin by writing that. The limit as x approaches infinity of g of x. Make sure you use the correct name. So let's look at what happens to the output values as the input values increase without bound. As we move to the right along the graph, the y values increase without bound. So as x approaches infinity, g of x approaches infinity. That's it for B part 2. C part 1. Determine if f is invertible. Sometimes this question will be phrased, determine if f has an inverse. We can tell at a glance that f will not have an inverse because it fails the horizontal line test. If there is a horizontal line that can hit more than one point on f, it will not have an inverse. Also, for a function to have an inverse, it needs to be either always increasing or always decreasing. If you see a graph that goes up and then down, you know it doesn't have an inverse. We will say no, f is not invertible. Notice that the word is invertible, not inversible. If the question was phrased, determine if f has an inverse, right now we would say no, f does not have an inverse. C part 2. Give a reason for your answer based on the definition of a function and the graph of y equals f of x. I need you to listen to me very carefully. Remember all that stuff I said about the horizontal line test and the fact that the graph had to be always increasing or always decreasing? You can't say any of that stuff right here. In another class, you might have learned that for a function to have an inverse, it has to be a one-to-one function. You're not going to say that here either. None of that is going to be accepted. I have spoken with AP graders, and they are telling me that they are going to be very picky about your answer to this question. So you are going to give the following answer word for word. F is not invertible because each output value of f of x is not mapped from a unique input value. Let me point out some key features of this answer. First of all, the order. You have to start with output value and then end with input value. Also, you must say of f of x, and you must use the word unique. Putting that all together, you basically have to say exactly this word for word. But guess what? If you say everything I just said word for word, you still don't get the point. To earn the point, you also have to give examples explaining what you're talking about. You must name a specific output value that is mapped from 2 different input values. For example, the output value of -2 is mapped from the input values of 2 and 9. To earn the point for this question, you must include a statement like this. For example, f at 2 is equal to -2, and f at 9 is equal to -2. By the way, if you're given a function like this that does have an inverse, you don't need to provide any example. You will simply say, yes, f does have an inverse because each output value of f of x is mapped from a unique input value. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.